problem 31C, let's kind of pick up where we left off on 31A. So we already had our drawing done earlier about what 31A was going to look like. And because it's gone, let me just kind of repeat that. So here's the jet at the beginning, here's the jet at the end, and there's the jet traveling. The jet starts at rest, and it reaches a speed of 165 meters per second, and it does that in 2 seconds. So in terms of listing our givens, we stated before that what we know is going to be, it starts at rest, so V naught is equal to 0. The time is equal to 2 seconds, and the final velocity is 165 meters per second. We also calculated earlier, and this is going to be important for us on this, that the acceleration of the jet is 82.5 meters per second squared. And that came from a solution to part A up above. Okay, so now on to part C. So I'm just going to mark through. We're not doing A, we're not doing B. We're going to go ahead and start with C. So on part C, it says how fast was the jet traveling after 1 second? So I've got some numbers here, but they're not for 1 second. So in this problem, what I'm looking for is I'm looking for this. I'm looking for t at 1 second, and my speed isn't going to be 165 because 1 second's somewhere in this part of the motion. So it's going to be a new speed there. But my jet's still going to start at rest, so that's going to be the same. Alright, so really what I'm after is a new set of givens, this time just for part C. I know it's going to start at rest, and the acceleration of the jet is going to be the same no matter how much distance it covers or how much time it flies on the deck. It's still going to be 82.5 meters per second squared. So that's still going to be true. It's asking for the time at 1 second. How fast is it going to be traveling? So I have V, V naught, A, and T. I need an equation that's got just those variables in it, and I got the perfect one for that. I've got V equals V naught plus AT. I do not need to isolate for the unknown because it's already isolated. That's the final velocity. So V is equal to the initial velocity, which is 0, plus the acceleration, which is 82.5 meters per second squared, times the time of 1 second. So this time the velocity is going to be 82.5 meters per second.